Okay, welcome back, guys. This is Miss Robinson, your third grade math teacher for the year. And this week is going to be our last week together. So I figured I took some stuff off of the HISD hub where some exit tickets, and we're just going to kind of go over a multiple different types of problems today. We don't have a specific objective except for to review different types of problems we've gone over this year. Most of them will have either multiplication, division, addition, or subtraction. All right, so let's get started. There's a couple parts to this. You know what? I'm going to cover it up and read what the sentence says about it and kind of write what I notice and see about this. The table shows the relationship between the numbers of bracelets that Tatiana sells for different numbers of dollars. All right, so I see the number of bracelets and the number of dollars. So I know some things I noticed. I know these are going to be dollars. These are bracelets. This is a smaller number. That hashtag sign just means number. This is greater. So that means I either need to multiply. I'm either going to multiply or add from this side, or if I was working the other way, I need to divide or subtract to go that way. It just kind of depends which way I go. I do know I'm missing these two. How many dollars it is for 9 bracelets and how many dollars it is for 13 bracelets. I also know whenever I'm creating a chart like this, I need to redraw it with the process in the middle. So I'm going to draw a chart over here. And it's going to have 3 columns. We're going to have the number of bracelets, the process, like how I'm going to solve it, and the dollars, right? How much it costs. And I have 1, 2, 3, 4, 5, 6. So I'm going to break this up into 6 sections. I know that for 2 bracelets, there's $8. For 4 bracelets, it's $16. For 5 bracelets, it's $20. For 6 bracelets, it's $24. But I'm not sure how many it is for 9 bracelets and 13 bracelets. Just going to give you guys about 30 seconds to look over what I've done and see what you notice about this and draw it if you have a notebook paper at home. You have your notebook at home. All right. So I know I'm going to need to figure out what the process is, but let's kind of see what the first question asks me about it anyways. How many dollars will Tatiana get for selling 9 bracelets? So right now we're looking at the 9 column, right? How many she'll make for 9? I first need to figure out what I need to do to get from 2 to 8, 4 to 16, 5 to 20. Whatever I do, remember I'm not finding the pattern down this way or this way. I'm trying to find it across. So I can either multiply or add to get from 2 to equal 8. Well, let's add first because we're all pretty comfortable with adding. 2 plus blank equals 8. Well, 2 plus 3, 4, 5, 6, 7, 8. 2 plus 6 equals 8. So that works here. Let's see if it works here. 4 plus 6 equals, 4 plus 6 equals 10, not 8. So this rule can't work for all of them. So now I need to try multiplication. So I have 2 times blank equals 8. Well, I know 2 times 4 equals 8 because if we double 4, it'll equal 8. 4 times 4 equals 16. Yes. 5 times 4, well, 5, 10, 15, 20. Okay, that's correct. 6 times 4, well, I add 4 to 20, 21, 22, 23, 24. Yeah. Now 9 times 4. Well, I know I can do 9 times 4. I can break 9 into 5 and 4. So it'll be 5 times 4 and 4 times 4. I can look here. I already found that 5 times 4 is 20. 4 times 4 is 16. And 20 plus 16 is 36. So this is 36. So I'm going to circle that for this part. And I know for 13 I'm going to have times 4 as well. All right, let's look at the second part. How many dollars will Tatiana get for selling 13 bracelets? Well, that's what we're trying to find next is 13. So we know we need to do 13 times 4 equals blank. Well, you know what? I'm going to break this up. I'm going to break this up into a couple different things. I'm going to break this up into, well, I know that, I know 11 is a high number, but I know I have 2 times 4 already. Now I need to break 11 up into 2 numbers I know. So I have 2 times 4. And I have 5 and 6 equals 11. So 5 and 6. So I have 2 times 4. Now I have 5 times 4 and 6 times 4. All of which are up here. We have 2 times 4 is 8. 5 times 4 we said was 20. And 6 times 4 is 24. Now I just need to add them. 20 plus 24 plus 8. 8 plus 4 is 12 plus 0. I put my ones place down here, bring my tens place up here. 2 plus 2 is 4 plus 1 is 5. So, Tatiana will get $52 for selling 13 bracelets. Okay, I'm going to leave this up here for 30 seconds for you guys before we move on to the last part of this problem. Okay, so let's look at the last part of this problem. What is the relationship between the number of bracelets and the number of dollars? So now we need to figure out the relationship. We know we multiplied by 4. So that means each bracelet must cost $4. We could say each bracelet costs $4. Because if we had to multiply by 2, that means each one bracelet costs 4, one bracelet costs 4, and 4 times 2 equals 8. We could also say the dollars, right, cost equals number of bracelets times $4. Or we could even take it one step further and say the bracelets, right, the number of bracelets I'll do number of B for bracelets, equals the cost divided by $4, because if I had $8 and I divide it by the $4, I'd get 2 bracelets each. All right, guys. Now let's move to a different type of problem. So we did a number pattern problem. Now let's look at something else. There's a lot of parts to this. A toy factory shipped 4 crates of toy airplanes. Each crate contained 96 toy airplanes. How many toy airplanes did the toy factory ship? So we want to see how many toy airplanes was shipped. We know there's 4 crates, and it says pictorial model and number sentence to set up your problem. But what I'm going to do is I'm going to also put my important information. Actually, I could put it right here. We have 4 crates and 96 toy airplanes in each. I just write toy for toy. It says it wants a number sentence and a pictorial model in this first box. So I'm going to make 4 crates. 1, 2, 3, 4. Now, does it make sense for me to draw 96 toys in each of those? No, I can't do that. So I'm just going to write the number 96. And this is 1, 2, 3, 4 crates times 96 toy airplanes. We'll get our answer. So now we're going to go over here and we're going to solve the problem. Before I do that, I want to look at this bubbling in part they give us. In 3rd grade, sometimes we make mistakes with this because we're not used to seeing it. I want to just go over it really quick. We have this thing called a decimal, which we don't do in 3rd grade. But the place value right next to the decimal is called the ones place, right? Then we have our tens place and hundreds. We always start with our lowest place value, and for us, it's going to be the ones place. 1 is the smallest whole we can have. This decimal will show us like parts of a number whenever we get older. So now I'm going to do 4 times 96. There's a couple ways I could break this up. I think that instead of breaking up the 96, I'm going to break up the 4 into 2 plus 2. So I have 2 times 96 and 2 times 96. And this is why. Because 4 is such a low number and 2 is even lower, I can just add 96 plus 96. 6 plus 6 is 12. I'll put my ones place down here, bring my tens place up here. 9 plus 9 is 18, plus 1 is 19. 192. Now I can just add these two numbers together to get my answer. 192 plus 192. 2 plus 2 is 4. 9 plus 9 is 18. Bring that that tens place up here. 1 plus 1 plus 1 is 3. So it looks like 384. I'm lining it up. My 4 goes in the ones place, 8 in the tens, and 3 in the hundreds. Then I bubble in what is in each one. I'm going to give you guys about 30 seconds here. All right, now let's look at what we have down here. It says use a different strategy to solve the problem. So what we did is we basically did a lot of addition in the form of multiplication, right? Repeated addition is what multiplication is. I want to try something involving, actual multiplication. I'm going to show you two different strategies. The first one is going to be breaking up that 96. So we have 4 times 96. I'm going to break up 96 into 90 plus 6 and 90 into 50 and 40. Now that seems like a lot, but it's really not, because, well, I can do 4 times 6 is 24. Now 4 times 40, all I need to do is look at the 4 times 4. I know that's 16. And then I put a 0 in my ones place. I add a ones place, so it becomes 160. Same with 4 times 50. 4 times 5 is 20. Add a 0 from the ones place, it's 200. Now I add these numbers together. 200 plus 160 plus 24. 4 plus 0 is 4. 6 plus 2 is 8. 2 plus 1 is 3. 384. Our numbers match. Now I'm going to show you guys in what we call like standard form or standard algorithm, because it is important to kind of understand what that looks like. We line it up, our 96 is on top, times, and we put our 4 down here. We first multiply 4 times the ones place. 4 times 6 is 24. I put my 4 down here. I'm going to add 2 after I do my next multiplication for that tens place. 4 times 9 is 36. Plus 2 is 38. 384. Give you guys another 30 seconds for this. All right, so now we're going to write if our answer is reasonable. Now we got all three of the same answer, so we know it's definitely reasonable. Yes, because we need to give an explanation. We did repeated addition, decomposing, and standard form to get 384 toy airplanes each time. We can also say it makes sense because 384 is definitely greater than 96. And it's definitely greater than 4, and we're multiplying, so we need a greater number. Also, 96 is kind of close to 100, and I could skip count 100, 200, 300, 400, and 384 is right under 400, so it is close to what we should get. I'll give you guys about 15 more seconds. All right. Let's look at the next problem we have. A PE teacher separated his 60 students into two groups. Each group had the same number of students. He gave one of these groups orange shirts and the other group green shirts. Then he formed teams of 6 per team. How many teams had orange shirts? So we're looking for teams, not people, teams with orange shirts. We know there's a total. The total is 60 students. There's 2 groups, and then 6 students per team. It says using a pictorial model and a number sentence to set up your problem. All right, so I'm going to draw a picture of, I'm going to make 2 teams. I'm going to make the orange team and the green team. And I'm going to make tally marks to represent students on each team. Now I know I have a total of 60 students and I want them to be equal numbers on each team. So I'm just going to do one at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. So now I know that there are, and what I just did here, first let's write our equation for this part. We did 60 divided by 2 equals, and let's count how much is on one team. 5, 10, 15, 20, 25, 30. Now it says solve your strategy here using your strategy, but we're kind of using pictorial form as our strategy, but we're not done yet. We know the orange team has 30 students, or the orange group, but we need to break those orange groups into 6 students per team. So what I'm going to do is I'm going to count to 6 and make a group. Then count to 6, make a group, and see how many teams there are. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18. 19, 20, 21, 22, 23, 24. I'm at 24 so far, and I have 4 teams so far. 25, 26, 27, 28, 29, 30. So I have 30, and I have 1, 2, 3, 4, 5 groups, and I just did 30 divided by 6 equals 5. Now remember, this is like a place value chart. I have my ones, tens, and hundreds. 5 is in the ones place. I just put a 5 here, and I do not need to put any. I line it up with the ones though. Maybe guys about 30 seconds, 40 seconds to see all the stuff we just did. Okay, now let's see what the rest of the problem wants us to do. Fill in the blanks with a numerical expression to write a summary of the statement of what happened to the problem. The PE teacher used blank students and blank teams had orange shirts. So the PE teacher used 60 students and 5 of those teams had orange shirts. Is our answer reasonable? Well, yes, because there's a total of 60 students. I put it into 2 groups. And then we had to separate the half of 60 into groups of 6. So it would only make sense to have a smaller number, which 5 is. So half of 60 is 30. And 30 divided by 6 players each equals 5 teams. I'll give you guys a little bit more time for this. All right, excellent job, guys. We went over some division problems. We went over a number patterns problem, and we really just broke it apart by the different pieces. And then we went over a multiplication, 1 times 2-digit multiplication. You guys did a great job. This is the last time we're going to be meeting for the year. It's been great getting to know y'all, and I hope that you guys have a great summer vacation. I'll talk to you guys later. Bye.